Welcome everybody, last video lecture of the week. And in this video, we're gonna go a little more into demo. It's been a while since we had a demo in the course, so that's what we're gonna do. And we also said that if there was a demo, we're gonna try to make the demo like a bit longer and record it, which is what we're trying to do right now. So I might go a little bit quick on the beginning. I remove some stuff because I really want to focus on how to implement and justify a design choice. And that's what we're going to do together. Why this lecture now? Because we talked about testing, so that might look weird. We realized during testing that at some point, the looking at the boundaries, if there's something or if this thing not here, was potentially a problem. It's such a problem that we have to define tests to handle it. So actually going back to the design realm and being like, okay, how can we design actually stuff that are part of like representing the absence of value? I'm looking for something and it's not here. Which kind of design decision can we take? And we're gonna use this kind of like a bridge from the testing course where we saw it was necessary to think about this. Then we'll look at how to implement it, which kind of like option do we have? And we'll also start really justifying what we're doing. So taking a decision, looking at the pros, looking at the cons, but in kind of like a systematic way, so that we'll do this for different examples. So the first things we're going to look at together is really this notion of internal state. There's something or there's not something. This can actually be generalized into the notion of state machine that you've heard of. And we're going to look at this. Then we'll see a case study. We talked a lot about game with cards. We played and we discussed Skoden Toten. In this example, we'll look at the joker. And the notion of the joker is that it's the card that doesn't have a color, but that doesn't have a value. So, well, all the cards in Skoden Toten has a color, one among six, and has a value from 1 to 9. But the joker, you decide the color and you decide the value when you play it. So it's kind of like you have the card, but just like you have to set those elements when you play it. So it's slightly different, and that will kind of like impact our specification. And finally, we'll take this and we'll look at how we can implement the different variants in Java, and we'll see like how it's represented in UML and also the pros and the cons, so that you get more confident when I'm saying you need to take a decision. Fine, you should know how to take a decision, but you need to justify your decision. That's exactly what you're going to do together. So to start with, designing internal states. The first question would be, what's a state? We talked a lot about encapsulation, information hiding. We said that, oh, data are inside the object. It's inside the capsule. No one knows. It's hidden. You just send message, and that works like that. Fine. But switching on the camera would be better. And now what we need to do is basically just think of, okay, but any state? Like, do I have a software engineering to consider each and every possibility for my objects? Well, we've seen in the testing lecture that doesn't sound like a good idea because it's just not possible. There's the input space, the possibility is way too big. So we just can't do that. So if we look at what the state could be, it's not necessarily the state at the implementation level. It's more conceptual, which is good because we're doing design here. So I'm designing the kind of state my system can be in. My card deck has card or is empty. A term is planned. We're currently planning next fall. Can be running. This winter, you have your course, you have your rooms, you have your instructors, mosaic is configured, like all those kind of things. Or can be archived. Last fall, we have legal requirements to archive course for 2 years. So we're basically keeping all the grades, all the documents and everything. And then when it will be done, we're going to be able to flush it. Your bank accounts can be positive, can be negative. So if you take a step back on all of those different elements, well, basically we'll see that states are kind of like exclusive. I'm in one state or I'm in another one, but I'm not in between. The card deck contains something or is empty. It's a running term, it's an archived term, it's a planned term. My bank account, I have money, I don't have money. And that has an influence on what you can do. If your bank account is negative, you might not be able to withdraw money. If a term at Mac is archived, might not be able to change grade. If it's running, I might be able to change an instructor, for example, but maybe not able to change a room because that's too late because we've after the add date, those kind of things. So you see, I don't care how many courses I'm running. I don't care who are the students. I don't care who are the instructor. I just know that my term is running. And because it's running, there's stuff I can do and there's stuff I can't. And really the motivation behind this is that if we work at the implementation level, being like each and every state that the program can take, because each and every value that can go in each and every variable, well, you see where I'm going, right? That's way too big. Just take Skoden Toten. So there's 54 cards, number of permutation without repetition, which is so the number of combination those cards can be ordered. It's, well, you get the formula on the slide. So basically it's 10 by the power 60 of 71, the order of magnitude. So it's close to the number of atoms in the visible universe. We don't want to do that. We're not going to code that. Okay, that just would not make any sense. So when we're thinking on our system in terms of states, because depending on the state, I can do stuff or I can't, I'm not saying each and every state. I'm really saying what is relevant. And that should resonate with you based on what we're seeing in the testing lecture. And that's why this lecture is right after the testing lecture. We're looking for relevance. If we're trying to be exhaustive, we just can't. It's just not possible. That doesn't make any sense to try this. So our job as software engineers is basically to analyze the domain, look at this and say, okay, in that context, this makes sense, and this makes sense. And this is what we're going to test. So those are the states that we're going to consider. You might be wrong at the first time. Not a big deal. Iterate, embrace failure. We made a mistake. We forgot about that state. Or the card deck, maybe it can be shuffled in addition of being containing card or empty. It contains card, I can shuffle, and at the end it's empty and I can't shuffle the empty card deck. Fine, I didn't know that. Now I know. I modify my design, I modify my code. I introduce a feature, refactor, redeploy, release, rinse and repeat. Okay, so really the objective is find what you know, and based on what you know, just represent those states and say, what can I do in those states? You drove your car this morning, maybe. Your engine in the car, it's on or off. I can't do stuff. I can't accelerate if the engine is off. I have parking mode, drive mode, reverse for the on the gear. Fine. If I had a manual one, that would also have to expose the clutch mechanism that I don't have with an automatic. That's actually related to information hiding. Like there are some stuff that are happening inside the car under the hood that I don't know about, because in the case of an automatic car, it's encapsulated. And in the case of a manual car, it's the user who has to interact with the clutch to be able to change gear. So you get this point. But overall, it's a notion of state. I'm driving, I'm parked, or I'm going reverse. So far in the UML, we've seen mainly two kinds of diagrams. Class diagrams, the different classes or relation, sequence diagram, the message exchanged between the different things. We kind of like slightly covered object diagrams in the lecture on life cycle, but that was just to show you that, oh, by the way, this is targeting object, not classes. We're doing object-oriented design, not class-oriented design. So the objects are the most important, and everything is about asking an object to do something for us. We'll see another kind of diagram in 2AA4, which is a notion of state diagram, and that will be the last one. So now we're done. We've seen all the new languages that were used in the course. And the notion of state diagram, it's basically to explain the life cycle of a given object. So on the left-hand side, I have my card deck that has a side. It's private, so that's why it's red. It's an integer, and my deck can be shuffled. I can draw a card, or I can fit it. Okay? And on the right, I have a state machine, a state diagram, an automata. There's lots of variation on the kind of semantics that goes behind this, and there's a whole lot of theory behind finite state machine, more automaton, mealy automaton, all those kind of things. We're just going to take it very, very simple. It has a start, which is this black box, and it transitioned to states. So those boxes, they're states of my deck. So at the beginning, my deck is empty. There's nothing. I'm just starting with the empty deck. And if I call the fill method, then I'm going into the complete state. And if I'm in the complete state, I can shuffle as many times as I want. I will stay complete. If I draw a card, I'm moving into incomplete. But if I fill it back, I'm moving back to complete. If I'm in the incomplete one, I can draw a card until my size is greater than 1. That's this brackets notation. It's a condition. It's a guard using the right vocabulary. And if I'm an incomplete deck and my size is 1, if I draw, I'm back to empty. You see? So there's no point into representing 10 by the power of 71 different states. I can actually live with 3 states: empty, complete, and incomplete, and that describe entirely the semantics of the different operation that moves from one state to the other. Starting empty, that's a design decision. I maybe wanted to start with a complete deck, but in this case, we're starting empty. And then I'm filling, I'm getting the complete one. I'm drawing, I'm getting the incomplete one. You get the point? So like MIS, we're not going to draw a state diagram for each and every class in our system, because that would be a lot of effort. What we need to do as software engineer is identify what is necessary, what is critical, what do I need to document, why do I need to explain, why do I need to be sure that it goes really through this life cycle when it's implemented. And then we draw a class diagram, because reading this, as soon as you get the syntax, which is this is where we start, this is a method that we call that moves from empty to complete, and this is a guard or a condition, then you're fine. You can actually really easily understand what's happening without knowing the details. I don't know how the deck works. I don't know how the cards are stored. I don't know what draw is doing. I don't know what fill is doing. I just know that if I'm incomplete and I'm calling fill, I'm going back to complete. How does that work from a code point of view? Basically the way you want. The only assumption is that this first arrow is what's happened when you build the object. So when you build the object, you should be available. And then the transition, their method called message sending. If my object receives that message and the object is in the available state, it's going to go into the occupied state. So this is a Zoom room, back to the COVID pandemic situation where everyone was teaching on Zoom. So how do I translate the fact that when I'm starting, I'm available? Well, in that case, it's just because, well, the occupied Boolean attribute is false, but that could have been done in a very different way. You see, it's not like a 1-1 mapping. Well, I'm just saying that when I'm starting, well, I should be available. And this is the design space. And if I move to the implementation space, then it means that, oh, in my code, I'm modeling the fact that this room is occupied or not by a Boolean. So at the beginning, this Boolean should be false. And then joining, well, if we call the join method, then I've joined the room, so it's occupied. And if I'm leaving, well, I haven't joined the room, so I left the room, sorry, so it's false. Okay, this is a very simple example just to show you this. And the point is just like really, there is no 1-1 translation from a design model and a code model. And that's the same with the class diagram. There's some stuff that you can't put in your class diagram that you can put in Java, like final, for example. The fact that the variable is final, you can't really represent this in the UML. In the UML, you can represent stuff that might not be immediately translated in Java. Same for MIS. There are things in MIS that can't directly be translated in Java. Why? Because Java is your tool. Java is part of your toolbox. That's a way to do stuff. But you have the blueprint, you have what you want to do, and then you use the tool to implement it. So if we think in terms of something a little bit more complex, just to show you that states can actually be a little bit more complex, instead of looking at the Zoom room, which would be available or occupied, we can look at the Zoom account. A Zoom account can be regular, and if you're regular, you basically can only host 45 minutes conference calls, and you're limited in terms of capacity. You can have more than 100 capacity, top of my head, something like that. Maybe that have changed. If you have a premium account, which is the case through MacMaster, Instructor, they have like premium accounts, which is paid by Mac. So we can have how many students that we want, and we can have like longer uh, conferences, sorry. The fact that this is implemented, we can say that this is bad design, that we should have inheritance, that we should have maybe an interface, whatever, but we don't care here. The whole point that this is how it's implemented. A Zoom account has a capacity and a wait room, and you can leave, join, upgrade, downgrade, or revoke. Okay? And what we're representing here is basically how we go between this. Again, we don't know how Zoom works. We don't know how those video streaming, audio streaming, blah, blah, blah. We don't care. What we just want to understand here is coarse grain level, what's happening when I'm calling a method. Well, what we're saying here, remember, this is initialization. So when I'm instantiating a Zoom account, the design decision is it's a regular one. And if I want to make it a premium one, I have to instantiate and upgrade. And that brings me a premium. And if I have a premium, I can downgrade, and that gives me a regular. Both case, if I want to get rid of my Zoom account, I will revoke. And by revoking, I'm reaching the end state here. And then what happened when I'm a regular? Well, when I'm a regular, I'm starting to be available. And then I join, and I can join with limited capacity. And if I leave, I'm being back to available. And if I'm a premium, I can have this notion of waiting room that I can't as a regular. And if I join, I can join full capacity. And if I leave, I'm going back to waiting. Get the point? We don't know the details because we don't care the details of the details. But just with this simple stuff, we're basically able to explain what's happening when we're creating a Zoom account. It's a regular one. How we move from one class to the other, regular to premium, upgrade, premium to regular, downgrade, and what's happening when you're a regular, what's happening when you're a premium. Okay? The details, not my jam. I don't know. I don't care. Not my problem. I just want to get this course understanding so that when I'm instantiating the Zoom account, when I'm using it, when I'm consuming it, I have an understanding of what I can do and what I can't do, and also what are the consequences of my actions. The main point here is to really focus on identifying what is relevant. Because, yeah, we use small example with Zoom Room, with Zoom account, with a card deck, but reality is complex, right? So there's two dimensions usually to identify those kind of like abstract states that we want to represent in our models. The first one is use the business logic. You can do stuff with your objects. Your objects are reflecting the reality. So can I shuffle the deck? Yes. When can I shuffle the deck? Can I draw a card? Yes, no. When can I draw a card? And you see that will give you to identify transition, and transition might help you identifying the states. And then you can also think from a technical point of view, what happens if someone drew a card from the empty deck? Okay, that should not happen. That should not be part of the model. And then there's no way if I'm empty to call draw. The only stuff that I should be allowed to call is fill, because anything is not specified. I could actually specify this and say, oh, that's an error state. Could have been an option. But here I'm just saying like, this model doesn't tell me anything if I draw from the empty card. Maybe I have a problem here. And this can be related to the notion of testing. If I take this, I can look at the test and I can say, empty, I can call draw and I can call shuffle. What happens if I shuffle the empty deck? What happened if I draw from the empty deck? It's unspecified, so my testing can rely on this state diagram to help me enriching the code and specification. But be careful. This is a specification. This is not an implementation. We don't want something that would be super, super fine grained, because this is not, this would be coding, okay? This is in my card deck. I'm starting here. This is empty. I can initialize it. That gives me initialize. Then I can draw, which gives me incomplete but ordered. And if I shuffle, then I'm incomplete but shuffled. Who cares? I'm just like, okay, it's incomplete or it's complete. And that might be the only stuff. Is it really necessary to remember that that is shuffled? Well, maybe for a casino where there's a legal requirement to shuffle the card deck each game or this kind of things, but for Scott and Totem, that is not necessary. As usual, the answer is it depends, but it depends on your business specification. So your role as software engineers, look at what you need and try to extract the minimal elements, minimal states that are relevant for your system. Why minimal? Because the less elements you have to take care of, the more time you have to do something else. So being minimalistic is really important in software engineering. Doing complex stuff, that's super easy. Doing easy stuff, that's super complex. So this is the first time you will start to design state diagrams. So you might actually encounter some classical flows or classical errors. The first error that you might encounter is that a state diagram is not a data flow. This is not a computational process. It's a state. Your object is something, and then you call, and then it becomes something else. So check in terms of cohesion. You need to be able to get relevance at the object level. Okay, I'm empty or I'm filled, I'm complete, and that's fine. The second point is that you will realize that you don't have enough. You try to be minimalistic, so you realize that you don't have enough state, and then you try to cover each and every possibility, and you obtain with way too complex state diagrams with way too many transitions, and at the end of the day, no one can read it, no one cares, so you've basically lost your time. Because if you create a design model that no one's going to use because no one can read it, it's useless. So you aren't going to need it. Just model the states that you need to support the semantics of your objects, the semantics of your interface, explaining, documenting to someone else what's happening if I'm calling that method. And the last one is modeling temporary fields, modeling stuff that are not really necessary, that can be derived from others. Like if I know your birth date, I can get your age. There is no need to have both at the model level because it just multiplies the number of transition, and I can actually use only one. So be careful with this. It's an n-type pattern, it's named temporary field, and that's something that goes like often. We might need those fields for optimization at some point, but in the initial design, that might not be part of that might not be necessary to have this as part of the element. So this being said, how can we design the absence of something? Now we know that we can model state, we have empty elements, we have complete elements. This is something that's going to happen all the time. We've seen during the testing lecture. I'm trying to get a file, I don't have access to the file. I'm trying to get a value, I don't have access to value. What's happening? So we'll stay in Skoden Totem, and it has this pretty cool card on the right-hand side, which is a joker. And a card in Skoden Totem, it's a color, there are 6 colors, and it's a value from 1 to 9. But there's one particular card, which is a joker. And the joker, so when I'm using it, Skoden Totem is about fighting, so you're basically using your card to fight your opponents. You're basically putting your joker inside your battle. And when the game is ended, you will decide which value this joker should have to get the maximal benefit. So I'm having the card, it doesn't have any color, it doesn't have any value. I'm playing it, it still doesn't have any color, still doesn't have any value. And suddenly, when I'm resolving the battle to know if I won or not, I decide which value it is so that I can maybe win the battle and kick my opponent. That doesn't work because what we said in terms of design is that we have the notion of card that is an enumeration that contains one element as part of the enumeration of color. It's an enumeration, there's only 6 colors, always be the case, so this is fixed, but there's only one, and it's 1, like I have to have it. Same for the card, it's a value from 1 to 9, there's only 1 to 9, that's why it's an enumeration. I don't want 10 or whatever, -1 as a value, so I know all my value, and that's again something which is specified here. I have only 1. Usually using UML, when you're not specifying a number, it means 1, but that's just a convention. If you really want to be sure, you want to really make something explicit, put a number. Can be 1, can be 0, can be star, to say that that might be multiple. I don't know how many, if it's a collection, those kind of things. So what we have here is that doesn't work. That with this, I can't instantiate a joker. It's not possible. Technical debt, we made a mistake. We didn't know that the joker existed when we did our initial design. Fine, now we can fix it. And we'll see that actually fixing it is way harder than what we can see. So how does it work? What are the states of the joker by itself? Well, when I'm starting, when it's drawn, I'm in the blank states. I have no color, I have no value. And then I can stop the game. I can actually end the game without never using my joker. Or I can decide which card it is, and then my joker becomes used. And when it's used, it has a color and it has a value. Okay? So to do this and to model those kind of diagram, you can use whatever tooling you want in the context of 2AA4. But if you're using Plant UML, which is the stuff used to draw each and every class diagram, each and every UML diagram actually in this course, that would be the syntax. I'm loading my styling system, and which is like the right colors and the theme and blah, blah, blah. And then I'm saying that there's a state named blank, and in that state, this is what's happening. This dot color is I don't know, and this dot value is I don't know. And I have another state which is used. This dot color is C, and this dot value is V. And then my entry points, this is bracket star brackets, that's this one, goes to blank when I call draw. Blank goes to used when I call decide. Blank can go to the end, and used can go to the end. Okay, by using used on the right, it helps Plant UML to put used on the right, and that's a better layout for the diagram. No need to use Plant UML in this course. If you want to use it, that's fine. Just need to install it, and then it's pretty cool. You can version your model, that's cool. But if you want to use something else, be my guest. Now the question we have is, because we have this, so we sought and design how the joker is working, we have a problem. Because this, I have absolutely no freaking idea how to implement this. And this is not possible in my design. I can't do that, okay? Because it needs to have a color. It needs to have a value. So what I would ask you to do is put a video in pause, like 2 minutes, and just think in terms of how to design the absence of value. What can you do to represent this? There are several options. If we're thinking in terms of Java, that's actually the case for a lot of language. We can use something which is just, oh, that thing doesn't exist. This is called null in Java. So that's okay. I can say, oh, the color of my card is null, but that also means that this object has a dangling pointer, a dangling reference, if it's really talking Java. And that might be a problem because null, it's not an object. So I can't really send message to null, but when I'm getting the color, I'm expecting a color, and I can send message to a color. So might be a problem. We'll see it later on. Other options is to create my own zero. I mean, if I want to create a list that contains nothing, I can ask the list class to give me the empty list. That's how Java works, actually. Math did it. Okay, they needed to represent the absence of value. Well, they created zero. So that's kind of like an option that can exist in my system. Second point would be to use what's called an algebraic data type. It's the same acronym ADT, but it's different. It's not an abstract data type, it's an algebraic data type, which is basically a thing that I can say, oh, my method, I can return a color, or I can return known, and that is get color. This syntax doesn't exist in Java, but what we're using to do this is named optional. We'll say that the signature of get color, it's an optional of color. An optional of color means that it can be a color or it can be nothing because it's an option. We'll see more in the implementation. Before jumping to the demo, I really want to emphasize the notion of null. Null is evil, and that's actually interesting. That's a quote from Tony Hoare, one of the people who invented Java from 2009. And he qualifies null as his billion-dollar mistake. It was like, oh, that was so easy to implement. That looked so cool. I put the null reference in Java, and now we have to live with it. So don't use it. Don't be that kind of software engineers. Really it's not good. We have to deal with it. We have to know that it exists. We have to take care of it because sometimes we have no choice, and sometimes we'll receive null pointers or null references. Fine, but when you're designing something, try to not use it. Or if you're using it, use with caution. That you know that okay, this can be null. Fine, but I've done my due diligence. I know I don't have any other choice, and I have a way to mitigate the consequences. And we'll see the consequences like just a couple of slides. Okay, so now we can move for the last 20 minutes-ish to how to implement optionality. What can we do? So to do this, there's a repository which is named absence of value that you can find on Avenue, and I'm going to navigate it with you and show you the execution and stuff like that. We're not going to live code together because it's kind of like a little bit tedious and a lot of copy paste on this one because we're just going to take color, card, and value and just kind of like explore some variants of doing this. So it's better if I can focus on just showing you the differences and the link with the UI. So let's move to the demo. So this is the repository that you can find. It's named absence of value. And what you have in this demo and in this repository is basically our initial design, which is here. And you'll see 5 variations of the design. And we're going to explore those 5 variations together. But the whole point is that, remember, there's a lot of different ways to implement a given solution to one problem. Problem space, I want to model the Joker. Implementation space, design space is like, oh, I can do it with this option, this option, this options. So those different options, we're going to call them design choices. And that's what we're going to explore. So what I can do so far is basically cloning this. And when it's cloned, so I spare you the cloning, but this is like my absence of value repository. I can maven clean as usual. So I know that everything's fine. Pretty cool. And I can maven package. Sorry. I can maven package. You will not catch the F tool on the camera. So that is package. So it has created something in the target repository, in the target directory. It's created demo.jar. So I know that I can execute this. Before executing something on my computer, that might be good to know what's happening. Okay, so how can I know what's happening on the Maven project? Well, Maven is all about convention. So I can actually go to the pom.xml and I can see what's happening. So say, okay, group ID, artifact ID, it's a demo about the 0 value. It's Java 21, code UTF-8. Oh, this is what's happening. This is what's executed. CA McMaster, SC2A4, absence main. That's good information. Then I could look at the rest, and the rest is basically, it's going to name demo. Well, that's what we saw. It's named demo. I'm just compiling. That's just Java BS. We don't care about it. And we're basically configuring with the main class being our main class. So that's fine. Now I know that when I'm running demo, it's actually calling this. So what this? Well, CA McMaster SC2A4 absence, that looks good. This is main. This is what's happening. So this is main, this is my entry point, public static void main string bracket args. And what we're going to do here is run A, B, C, D, E. Okay, so it means that each situation is modularized as a method. And this is my A method, this is my B method. So, okay, that's pretty fine. I have no idea of the details, and that looks pretty crappy code. I just entering the project, and this is the kind of path you can take, saying, where do I start? It's Maven, so it starts with the POM that contains the information. It tells me where the main class is. I can look at the main class, and I can look at the entry point, and then I can use this to just slowly drift into the project and start understanding what's happening. Okay? So what we need to know now is what are we doing? So now we know that the code exists, we can actually execute the code. So I have confidence that that makes sense. So I can java-jar targets demo. That works. I don't know. Oh, there's an error, whatever. I don't know. I don't care. I just know that I can execute it. So that's fine. Now you can see, I can look at what's happening, but I've solved my technical issues. I can clone, I can clean, I can package. I know what's happening when I'm packaging, and I know I can execute it. So now I can put effort in the code, because if I'm starting putting effort in my code before even knowing that I can compile it, effort is totally lost, because I might do stuff that I will never be able to deliver because I don't know how to compile it or it doesn't work. First things first, you're entering a project, do exactly what we just done. Compile, check that you clone, sorry, check that you can compile, check that you can execute, look at what you're going to execute before executing it. That might be safe for the computer, actually. And here we go. So now that this is done, we know we can do this. Let's look at the README. Let's look at what's happening. So we're considering card gain from Skull and Totem, cards as value in 1-9, and color, there are 6 colors. Okay, that's my initial design. I have the enumeration of colors because there's only 6 colors: green, blue, red, yellow, purple, brown, and there's 9 values. And we're using an enumeration here because I don't want 10, I don't want -1. Those values are actually ordered from 9 to 1. That's related to the comparison lecture, and we're good. The kind of design decision we're seeing here is that there's no setter. So when I create a card, it's done once and for all. Might mean that the card is final, actually, like the color and the value attributes are final. Maybe, I don't know, UML can't say it, can't tell us that. And what I'm also saying that this card contains a color, which is named color, and the minus in front means that this is private. Okay, it's encapsulated. Same for the value, it contains a value that is encapsulated because there's a minus in front. So that looks okay. I mean, as soon as we don't have to talk about the joker, we're pretty fine. I create my card once and for all. I can't change it because, well, that physical card can only have 6 colors, can only have 9 value. Pretty fine. Now comes my problem. I didn't know when I did that, or I forgot, or I postponed the decision that I need to model the joker. Fine, that software is soft, so I can use that softness and fix my design. So my first way of doing it will be to use null. Okay. So what we're going to say is that a joker is a card that had the color and the value set to null. What we see here is that there's lots of differences between this and this, because just doing this gives me more constraint for the joker. First off, I need to be able to create the joker. So I need to create this constructor, which is, oh, a joker is color is null, value is null. Okay, I could have put null as parameters, but I want to have it here. Then I have the get color and get value, but I need suddenly to have setter because I need to be able to set the color of a joker and set the value of a joker. And I also need to know for a card if it's a joker or not. Okay, so my modifications here were really done not on the color side, not on the value side, but really on the card level. We're going to see how it looks at the code level. But first off, just to show you how PlantUML works, PlantUML being the tool used to represent this, we can go in src main PUML for PlantUML, and we have the description of the model, actually. And this tells us this is a style, this is just like some layout parameters, but this is how I model my class. Okay, I'm saying, oh, it's a class card that has a public method, which is this, and a public method, which is a constructor without parameters. And then I'm putting a separation, get color, set color, separation, get value, set value, separation is joker. And then I'm saying color, it's linked to card, card is linked to value. And this is the way I draw the line, the arrow, and I'm putting this little star here so that I'm actually obtaining this little black diamond, which says this is contained, my card contains a value. Okay, so you can use any kind of tooling to draw your models. PlantUML is pretty cool because these can be part of my Git repository. So I can actually have this, and I have a makefile that actually produce all the pictures in vectorial format, so that can scale, that can be integrated into documents, into slides, all those kind of things. But again, use the tooling you want. So let's look at how it is. First, the notion of color. Well, color, it's an enumeration, so green, blue, red, yellow, purple, brown, pretty natural. Value from 9 to 1, again, enumeration, pretty easy. let's look at the card now. The card has a private color and a private value. Those can't be final because I might have to change them later on. So if I put something final, it means that this is done once and for all and you can't never change it again. So I'm removing this from my design. Now, color and value are mutable. And we've seen in the MIS-ADT lectures that mutability triggers problems. So the most final elements I'm working with, the less trouble I will have because I know that this is never going to change. I'm adding this card constructor, and to know if something is a joker, well, I'm checking that the color is null and the value is null. Okay, and that's it. I have my new design that basically just introduced that notion of joker. It's meh because, like, if we go back to the README, you will see that there's a little analysis here, which is my design choice, joker either card, consequences. I need to add setters so that I can modify the color. Okay, but that also means that now any card can be modified, which kind of sucks. And also we'll see that the getter, now when I'm getting a color, if it's a joker, I'm going to get null. But null, it's not an object. So that can throw null pointer exception if I use it as an object. This is called an abstraction leak. We took an internal design choice, which is color and value being null, that's a joker. But suddenly, because we have a getter to this internal design choice, this design choice leaks to the outside and pollutes other people. Okay, so we just broke encapsulation, information hiding, all those kind of things, because now our internal decision is not internal anymore, and people need to take care of the internal decision we took. Let's see the impact on the code. So if I go back to main, run A. So what we're doing here is basically, this is annoying because we're going to use different flavor of card, color, and value, each one in a different package. So we have to prefix with the right package so that Java just compile. We're creating the card deck. So we're creating a set of cards. And what we're doing is that we're iterating over all the possible colors. We're iterating over all the possible values. And so we're creating a new card, which is this color and this value. And when this is done, it gives us 54 card. We're adding the joker. Another cons here is that I need to know as a user that creating a card without parameters is a joker. That's not really straightforward. That requires to read documentation. And then as a user, I can want maybe to print, like to inspect the contents of all the elements in my card deck. And to do this, I will be like, hey, card, give me your value, toString. And hey, card, give me your color, toString. And this is where using null is the root of all evil. Because when I'm going to call this, if this is a joker, it's going to say null. But null is not an object. So I can't do null.toString. That's a null pointer exception. So this is why this demo code is surrounded by a try-catch, because this, when we're going to find the joker in the card deck, this is going to throw a null pointer exception, because I will call card.getValue expecting a value, because, well, it's a card, so it's supposed to have a value, and suddenly it doesn't. And that will break. So now, because of this, it becomes my responsibility to iterate over all the cards and check if the card is a joker. And if it is, I can say, oh, I found the joker. Okay, so we took a design decision, used null, and by taking that design decision, well, now when I'm calling the card, I need to do way much more than before, and that doesn't look really comfortable doing this. And that is the execution we had. Okay, we run this. I've deactivated the other part of the demo, so you basically just have what's happening, and we're starting. So creating doesn't show anything, and then we're going into that loop, which basically iterate and print. So what's happening? We're going to find 2 brown, 5 green, blah, 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 and then suddenly we end up here, and it says that, oh, I can't call value.toString because get value is null. So that's an exception. That's an error. This shouldn't happen. And then I can also iterate and say that I found the joker. So yes, sure, I can model the joker that way, But at the end of the day, it starts to be pretty heavy for the user, and that can explode at runtime, which is an issue. So I can go for my second way of modeling this, which will be, actually keep this. Well, we're using objects and classes, so can't we use inheritance? Okay, so my design choice here is let's model the Joker as an extension of the card. That gives me interesting stuff. First, I need to change the visibility of color and value. Now they need to be protected because they need to be accessible from the Joker. They can't be private anymore. So I'm kind of like enlarging a little bit the encapsulation scope. But that's fine. It's just my children classes. That should be okay. Instead of returning null, I can redefine the behavior of getColor and getValue to throw unsupported operation exception, because calling getColor and calling getValue doesn't make any sense if I'm the Joker. And I can also set the color and set the value. But doing this looks okay, but is actually wrong. That would not work. Because if I'm doing this, I have a Joker, I'm setting the color, fine, but now I still can't get the color because now my Joker is not a Joker anymore. It has a color and it has a value. So I should actually implement something that transforms the Joker into a card and replace it inside the deck. That doesn't look great either, actually. But anyway, let's still consider this. If I'm doing this, so in terms of coding, well, my coding is basically have a card, protected color, protected value, creating the color, creating the value, which is fine. I need to have a protected card default constructor because this is how inheritance work in Java. I'm just exposing get color and get value in the card. That is pretty cool because now a card can only be readable. So my card is back to immutability. That's a good point. And then my Joker is basically when I'm calling the Joker, value or null, I'm overriding get color to say you can't get the color of a Joker, but we'll see that this is actually wrong because that will not work in the general case. And I'm putting the set color to the Joker, which is better because now only a Joker can change his color. And there is no modification on the color and no modification on the value. Let's see how it goes from the main point of view. Yep. So my second experiment here is basically to say that I'm running with inheritance. So I'm doing the same business logic. I'm instantiating each and every card. Then I'm creating the Joker. This actually looks better because this loop say basically go for each possible color, go for each possible value, create a card containing this color and value, and then add the Joker. That's okay. But now, before I had a null pointer exception, and if I run the same code, now I might have an unsupported operation exception when I will find the Joker instead of the of a regular card. It's a little bit better, but this is still not reasonable. This is not what I want to do. So if we go for the, so I will deactivate the first one. I will activate the second one. I will name a package and we'll run the demo with P. So when I'm running the inheritance, I can actually go through all of those and I will end up with something here, okay? Because basically what I'm running is I want a value, I'm catching the exception, and I should actually get an error message here. That's pretty weird. I might have to look at the demo and fix it again. But the whole point is that it's still my responsibility to try to catch this, and that might be an issue. So overall, at the end of the day, it is now my responsibility to look at it. And contrary to the previous one, if I want to know if something is the Joker, I have to check that this card is actually an instance of the Joker. And that's not what I want to do. You're not supposed to use instance of, because each time you're using instance of, you're breaking the type system. So that is pretty weird. So this solution, again, not the right one. Okay, that sounds not, we have more cons than pros. The setters are only exposed in the Joker class. That's good. We create a Joker by calling new Joker. That is also good. Mean that we have to create this protected because of technicality in Java. That's meh, but okay. The attributes needs to be protected. That's also meh. It's not a pros or a cons. It's just like, okay, can do better. And the getters also run unsupported operation exception. So we're leaking, again, an internal choice. Maybe not good. So another options could be to use default value. So we basically go back to the idea of not using inheritance, and we're going to initialize the joker as one blue. So there will not be any null pointer exception. Okay, a joker is a one blue, and we add this temporary field here, which is, oh, if you're a joker, then actually remember it. So if we look at the code, this one, this, sorry, color is the very same, value is also the very same, no changes here. And card, what we're doing is that when we're creating a card, the joker is false. And when we're creating a card by default, the joker is true. But we put a value here just to avoid throwing null. So get color, always return color, get value, always return the value. If it's a joker, I'm returning the fact that this is a joker. If we go to the main and look at what's happening, so by running null as a value, we're basically doing the very same. So I'm instantiating each color, I'm instantiating its value, I'm creating a card for each combination of color and value. Then I'm creating a joker, back to this, creating an unspecified card. Not that awesome, but why not? And I will print the sides. And then what now I need to do is to be sure that there is no duplicate because now I have this one blue that is in between. So I might have two one blue, and that might be an issue because this should not be the case. So this design choice, again, leaked to the user, who now has to take care of checking the color and checking the value and being sure that this is a duplicate or not if it's a joker. That looks pretty weird, but we can go back to it. So we can go here, we can basically deactivate this stuff, and we can activate C, name the package, and rerun the demo. And that tells us that there's actually 55 cards, which is exactly the number I'm expecting, 54 plus a joker, but I'm finding a duplicate. I have a one blue and a one blue that happens to be the joker. And I also have a one blue that is a joker and another one blue, which is a regular one. So by doing this, I might take the joker for one blue by mistake. Or if I'm encoding that one blue might be a joker, then it's really, really super strongly coupled to an internal decision that should not be the case. So yes, I can do it that way, but that doesn't sound like a good idea. And you'll have it like, it gives us really no point. I need to add an extra state. So it's this temporary field that we discussed in the state lecture. Now I can mistake a one blue for a joker, and the joker for one blue actually, and the setters, they're back to the notion of card. So not good. Let's look at another design. In this case, I can create my own zero, saying, oh, you're a color, but you're known, and you're a value, but you're known. So when I'm creating the joker, I'm actually creating the joker with no known. It has no color and no value. It starts to be a little bit more like a business logic. I still have to put setter. I still have to have this empty element here, but that looks like okay. And each joker now doesn't rely on an extra state. I can define each joker by saying like, oh, you're known and you're known. So that's fine. So how does it work at the code level? Well, we have to modify the color to add this new value. Like a color can be green, blue, red, yellow, purple, brown, and known. Value can be 9 to 1 and known. And then my card has a color and a value. If you give me a color and a value, those are those. If you instantiate empty, then it's known and known. This can't be final because I need to be able to set the color and set the value. And are you a joker? Sure. If your color is known and your value is known, then you're a joker. Let's look at the main for this design, which is the run 0. Doing the very same, I'm instantiating each possible value, I'm instantiating each possible card, and I will basically just print the size of the deck. Very same, let's go here. Save the package and run. Oh, my card deck was supposed to be 55 and now it's 71. Why? Well, basically because of my design choice, I can't do that anymore. You see why tests are important? I should have a test somewhere that say that the card deck should be 54, 55 cards, because if not, here I've just created a 1 known, 2 known, or known blue, known yellow. And that's not what I wanted to do. So now, because of that design choice, people can't iterate over all the values and all the colors because there is one specific value and one specific color that I can only use in a given way. So that sucks. And that's precisely where tests are helpful. You got a design, you got some properties on your design, and you made a refactoring, you took another decision, you introduced a feature, and suddenly, bam, you broke something that was okay before. So that's a real point that you need to take care of. So it's a little bit better from a business logic point of view because I really modeled that my card that has known as a color and known as a value is a joker. That's exactly what a joker is actually. So that's okay. And it's really like the color is known and the value is known. It's not null, it's not a default value or whatever. It's really like I've re-hi-fied, I've modeled that this can be known. And I still have the setters. And now I have my abstraction leak, which is different, but our internal design choice leaked to the outside. And actually now I can't instantiate the card deck the way I was doing it. Okay. Finally, the last options we're going to use is to look at what's called in Java optionality, but that's what we call in the lecture algebraic data type, where we use the notion of zero provided by the language, which is using optional. How do we represent optional in UML? Well, you can use this notation saying that get color will return a color or known, like it's a 0, 1 color. Some people would put a star. Some people would add like optional. It's not really in the language. So just use something in a consistent way that you can say this. How does it work? From a code point of view, my color is back to what it was. There's no known anymore. My value is also back to what it was. There is no known anymore. My card now is pretty back to what it was, okay? Card, color, value, card, nothing to do. If you're asking me for the color, if it's null, I will return empty. And if it's not, I will give you a color. So the signature here is I'm not giving you a color, I'm giving you an optional of color. Same for the value. I'm not giving you a value, I'm giving you an optional of value. If the value is null, you're going to have the empty value. If the value is not null, you're going to get this value. Okay? How does this work in the main? Well, in the main, I can now be back to creating the right stuff. So I can iterate over all the value, all the colors, create all the cards, add the joker. This is still creating an empty card. I'm not really liking it, but why not? I can check the size. And now I can iterate over this and I can run like, give me the color and give me the value. No null pointer exception here. And what's going to happen is that we're going to command, we're going to get this, we're going to save, Maven package, and rerun the stuff. Somewhere here, we're having optional. So all of those mean that this is optional. We have our elements, and those elements are optional, 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 optional. So what we open here that, oh, ooh, by the way, there's one card which is empty, empty. This is my joker. All the others are brown 7, blue 9, blah, blah, blah. But this one is empty, empty. Okay. This is still a little bit of abstraction leak because it's still up to me to actually know that now color is not immediately a color. I can check if there's a value or not, but it's done in a way which is a little bit more encapsulated than the way it was done before. So that will conclude the demo. And again, you can find all the stuff, all the pros and cons and all the kinds of sets, all the things that we discussed here. And if you want to practice, a good practice is that I left as an exercise, explore this stuff. It's a pretty simple project. It's a simple problem. So how would you do it? How would you model the card, the joker, in a way that makes sense? Try to do it. It's pretty cool stuff, and that takes you like 20, 30 minutes. You can experiment quite easily, and you can play with it. Feel free to clone the repository. Feel free to actually work on it. And if you have something that you like and you'd want to include in the repository, just send a pull request, and we'll consider integrating it. So this is a recap. We took 5 different design decisions. None of those decisions is best than the other one. There's that are really bad, like the null that can explode, the inheritance that was not really helpful and was overcomplicated. But all the others, they have pros and cons, and none of those are kind of like satisfactory so far. But that's exactly the essence of design. We're exploring different solutions and we're trying to find the best one, which is why design and development requires time. If you wing it 2 hours before the deadline, you will not end up with this understanding of the problem, and you will have no idea why you chose this instead of that. And this is not what we need to do, because you need to be in control of your design choices. So to conclude, designing internal states, we're going to use state diagrams to find what is relevant. And we use it as documentation for things that make sense, that are critical, like we did for the MIS. We're not going to do it for each and every concept in the product, but if we need to do it for one, let's do it for one. Handling the absence of value, it looked like a pretty basic and stupid problem. Oh, I have card and now I have a joker. How can I introduce a joker in my card deck? And it took us like a solid 35 minutes just to see 5 design choices that are actually not ideal and can still be perfected. Okay. This is also related to definition of done. Where should we stop exploring when we have something which is good enough? And how can we define good enough? By getting the specification, getting my test cases to know that everything's fine and that I'm working with this and that I have sufficient code and sufficiently good interface to work with this. But sufficiently, that's your expertise to define it. There's no like golden threshold that you can go through and like, okay, now it's sufficient. Okay, which is why you need to try, which is why you need to experience. And that's why assignment 1, assignment 2, and assignment 3 in this course are designed for you to experience those kind of things. And based on the live demo, you have like, yeah, there's no silver bullet solutions, there are always pros and cons. And remember that your job as a software engineer is to be able to analyze this. It's okay that you're not delivering something perfect. That is fine, as long as you can deliver something and analyze it and say, yeah, those are the pros. This is why it's good. Those are the cons. This is why it's bad. And this is why I've delivered it. That will conclude this pretty long video, but you were asking for demos being more like comprehensive. So we'll leverage the fact that that was done as a asynchronous video. Enjoy your week and see you next week, where we'll be back to boring in-person lectures. Thank you very much.